Today Jamie, Vanessa, and I are going to talk about the Kepler Space Telescope. The Kepler Space Telescope is manufactured and designed by NASA to find Earth-sized planets outside of the solar system. It's in a solar orbit that follows Earth but does not orbit Earth, so it will not be covered by Earth and can carry out astronomical observations on a continuous basis. The photometers of the Kepler are also not affected by diffuse light from Earth, and in its orbit, it's also not affected by the Earth's gravity and transient torque in Earth's orbit. This is the wavelength of the electromagnetic wave that Kepler can detect, which is about 4 to 900 nanometers, which is basically visible light. Kepler is a complex spacecraft including telescope, sun-shaped solar array, solar modules, and Huygens antenna, etc. But the core component of the observation is the focal plane. It consists of a CCD camera of 1.4 meters, which is the largest CCD camera launched into space.
So, before I explain how to manage data, I will introduce this display, which is called the Laboratory for Atmospheric and Space Physics. And this place is for monitor the Kepler telescope and receive and upload the data, and also send this data to other places like the laboratory or university for predict and research. I know this picture appeared for last time, but the full name of this equipment is the Charge Coupled device, which is also called CCD. This equipment is using for obtain pictures and then to the digital signal and then send it to this laboratory by the X-band. And as you can see, there are 42 pieces of CCD, and it's not in a plane. It looks like a curve to make the field of view over 100 degrees to get more accurate observation. So this is process of managing data. Here is the speed. Downlink means from the telescope to down to the laboratory, and uplink means from the laboratory up to the telescope. About noise correction, because Kepler is a little bit complex, and here's a picture of the primary mirror. It's very large and also contains 42 CCDs, which means that when this machine works, it will release huge amount of heat, and it will be a little bit noisy, and this noise is access scientists' expectancy. And it also will affect the quality of the picture. But it doesn't mean that but it still do very well. It's much better than any telescope on the Earth. Designer and scientists try to fit this problem by creating a software, but it's very hard to solve it, and until now they still cannot do it. So, for reaction wells, this equipment help to get more accurate observation. But after 4 years Kepler launched, 2 of them are broken, which means that Kepler cannot do the accurate observation like before. And then turn to the second mission, which is called K2. This is the rotate for K2. It's like an S. And the main mission for K2 is just identify some dwarf planets by their location and their characteristics things.
Well, why the government prefer to spend such more money to support this event? Of course, there are many factors, but the most important is the scientist value. According to the U.S. space agent, NASA's Kepler space missions has retired after running out of the fuel needed for the further scientist operation, bring an end to a prolific 9.5-year missions in which it discovered for about the 2,600 interesting places outside our solar system, and some of which may harbor life. The NASA reported that the data collector from the Kepler space mission indicates that our sky is full with the millions of hidden planets and more than the star. The science return of the Kepler's mission have been scaped and changed our view about the universe. In that we now think there are planets just about everywhere, and Kepler has so far detected for about 2,600 candidate planets orbiting distant stars, including many the Earth-sized planets, and within their stars' habitable zone, where the water can be extended with the liquid form. It is very sad that the Kepler mission can't go on any longer, but the taxpayer did get their money's worth. Thank you for watching.